section 4.1. The most important part on this section is when you are changing degrees to radians, you multiply by pi over 180. And when you're changing radians to degrees, it's 180 over pi. So that's a degree. My board's not working. We'll see if it works partway through. So if we're switching 30 degrees, if we want to switch that to radians, you have to multiply by pi over 180. Okay, so all I do is I go 30 times pi and I get 30 pi over 180, and then you can reduce the fraction. So I can divide by 10 and I can divide by 3. So I actually end up with pi over 6. Okay, so that's all you do for all of these. If you're switching it to degrees, you times it by pi over 180. If I'm switching it to I'm from radians to degrees, so I would have, so here's my radian, 5 pi over 4, and I want to switch it to degrees. I would times by 180 over pi. Okay, so in here I have a pi in the top and 1 in the bottom, so those can cross off. And I can simplify the 4, and 180 divided by 4 is what? Anybody got a calculator ready? 45? Okay, so then I'd have 5, and I would have 45. My board is horrible. And so 5 times 45 is 225. So the degree is 225. Okay, if you see D, it's 2.57. That's still a radian, it just doesn't have a pi in it. So you'd still be timesing by 180 over pi. So you just go 2.57 times 180 divided by 3.14. I can write that down. So for D, 2.5, my board doesn't like to write today. 2.57 times 180 over pi. So I'm just going to go 2.57 times 180 divided by 3.14, and you'll get 147 25. Okay, so if it says determine one positive and one negative angle that is coterminal, we have to remember coterminal just means in the same position. So if I drew an angle, so say I drew this and it was 30 degrees. Oh boy. This is 30 degrees, this angle. Coterminal means it looks the same, but it's a full rotation around. So if I went all the way around and then 30 more, a coterminal angle would be, how far is it all the way around? 360 plus 30. So a coterminal angle would be 390. Come on. Okay, so for example 2, it says the degree is 40. Well, that's just exactly what I did, except I did 30. So you'd go 40 plus 360 to get a positive one. So that could be 400. And if you went 40 subtract 360, you get negative 320. Because all it said was it wanted one positive coterminal and one negative. So to get it to be a negative, I subtracted 360. Okay, so for B, it's already negative. So if I add 360, I get negative 70. And then if I add 360 again, then I'll get 290. Okay, so those are two coterminal ones. 360, yep. And I mean, and you could do that multiple times, keep doing that and doing it, and you'd still get coterminal ones because it's just more rotations around. Okay. So then on the flip page, it says any given angle has an infinite number of angles coterminal. So that's what I just said. You could do this multiple times and just keep getting coterminal angles. So it says express the angles coterminal with 110 in general form. Identify the angles coterminal with 110 that satisfies this domain. So they just wanted anywhere between negative 720 and positive 720. Okay, so if I wrote it as 110 subtract 360 to the n meaning how many times I'm going to go around. Okay, so if n was 1, then that was once around. If n is 2, then that's twice around. Okay, and it's also 110 plus 360 n, meaning I could keep adding 360 n amount of times, so 1 time, 2 times, 3 times. Okay, and I just stop when my domain's outside of 720. Okay, so in this case, I might, if I subtracted 360, I might have negative 2, these aren't going to write good, negative 250, negative 610, and I'd have to stop because the next one would be more than negative 720. And then if I added 360, I would get 470. And that would be it, because the next one would be 830. Okay, so these guys would fall within that range. Okay, and then all we have for example 4 is we're trying to find the, oh come on, the arc length. So to find the arc length, the formula is A equals, and I have it top of mid-page for you. We have the degree, but the degree has to be in radians. That's supposed to be an R. Okay, so if it's not in radians, you need to make it into radians. Okay, and then you times that by the radius. Okay, so your degree in radians times the radius. So in this question, it says Rosemary is taking a course in industrial engineering. For an assignment, she's designing the interface of a DVD player. So it looks like this. It has the diagram is right there. I'll try to draw it, but so this is 130 degrees, and this is 6.7. So that's the radius. So we need to switch that 130 to radians first. So I'd go 130. And I'd times by pi over 180 to switch it to radians. Okay, so I would reduce, and I'd end up with 13 pi over 18. So that's in radians now. So I can find my arc length by going 13, doesn't like making 13s, pi over 18 times, what's my radius? 6.7. Doesn't like making 7s either. Okay, so if I go 13 times pi divided by 18 times 6.7, Can somebody do that? I don't have the final answer written on my sheet. So we need 13 times 3.14 divided by 18 times by 6.7. And that will give us the length of the arc, so this piece here. $15.19. Perfect.